Good afternoon, professor and colleagues. Today I'm going to expose about gas and steam mixtures. One exercise. Let's see. The dry bulb and wet bulb temperatures of atmospheric air at a pressure of 1 atmosphere are measured with a rotary psychrometer. Its values are established to be 27 and 17 degrees Celsius, respectively. Determine the specific humidity, the relative humidity, and the enthalpy of the air. As you can see from table A4, there is no exact values at temperature 27 and 17. So that's the reason cause I interpolate. At temperature 1, after interpolating, we get that the saturated pressure is 3.5678 kilopascal and the saturated vapor enthalpy is 2550.1 kilojoule per kilogram. And at temperature 2, the heat of vaporization of water is 2460.6 kilojoule per kilogram. And the saturated water enthalpy is 71.3579 kilojoule per kilogram, and the saturated pressure too is 1.9381 kilopascal. Also, from table A2, the specific heat of air at constant pressure is 1.005 kilojoule per kilogram Kelvin, and the data given by the problem pressure is 1 atmosphere. Then the specific humidity W1 can be found by the following equation. But before, we need to calculate W2 first. And it's easier than W1, as you can see, and it's after replacing 0.0121 kilogram water per kilogram dry air. And then W1 would be, after replacing 0.00796 kilogram water per kilogram dry air. The relative humidity phi1 is determined by the equation, this equation, W1 times P divided by PQ1 times dot 622 plus W1, and after replacing we get that phi1 is 35.9%. The enthalpy per unit mass of dry air is determined based on the equation. But remember that the second equation is an approximation. And after replacing, we get that enthalpy of air is 47.43 kilojoule per kilogram dry air. And that's all. Thanks.